Hello, and welcome to Game Gems. Now that Whodunit has released, I am hard at work doing research into features that I'll be using in my next couple of titles. Specifically, incorporating Synty's character models into Godot and animating them with Mixamo. As a result, I had to do a deep dive into the FBX importing process and learn a little bit about what some of the options actually do, as well as the ins and outs of creating animation libraries. I thought I'd share these discoveries with you all as, again, most of the videos on these topics that I can find on YouTube are either extremely old and out of date, or require mucking around in Blender. So let's get started. Here you can see that I've copied a character from Synty's brand new sci-fi horror pack into Godot, and now we've got a few problems. While Synty's older character models have a single mesh and skeleton, here they decided to be clever and take the same approach they did with their modular fantasy characters, which is to stack all the character meshes onto the same skeleton. They did this because the Unity version of the model contains some companion scripts and shaders to allow for customization, but we use Godot, so we have to do everything ourselves. Now, you could just enable the visibility of the mesh you want, but all the other meshes will still be hanging around and invisibly taking up memory and processor time. If only there were some way to only import the meshes that we want. Oh wait, there is. Find the original FBX file in your Godot project and double-click it to open up the import window. Whoa, that's a lot of options. Fortunately for us, the one we want is right up top. Click on the mesh you want to import and make sure the Skip on Import property is unchecked. Now, and this is the painful bit, go through all the other Mesh Instance 3D nodes and check that box. Once you're done with that, check the box to skip the import of the animation player as well, as the one embedded in the model doesn't import in a way that works correctly in Godot. We can make our own in a moment. Okay, now click Re-import. If you create a new inherited scene from this model, you'll see that only the mesh you selected is part of the model. This does mean that if you want to use different meshes, you're going to need to go through this process multiple times, but hey, what are you going to do? Save your new scene, but remember to add an animation player node first. Normally, we'd be ready to import some walk cycles, but wait a tick, what's up with the material? The model's all black and white and stuff. This is because if you look at the material embedded in the model, it's got now albedo texture. Fortunately for us, Synty provides a bunch of them, so let's make our mesh unique, then do likewise for the material, and everything but the skin is now properly textured. Wahapa. Well, in this particular case, Synty got clever and added some custom shaders to the model that, I presume, allow you to select a skin color rather than simply be stuck with the original like on their older models. Are we cooked, chat? Not at all. It's time to write a small shader of our own. Now, if you've never worked with shaders, don't panic. They're both pretty damn powerful and easy to learn the basics of. In fact, the basics are all I know. You can accomplish some really amazing shit if you take the time to master them, but we're not doing that today, thank God. Anyway, let's replace the standard material 3D with a shader material, and in the dialog that prompts us, select a place to save it, and make sure its type is set to spatial. Also, for some reason Godot pre-fills the file name in with the resource ID, and that'll give your OS fits, so give it a name readable by humans. Once you do this, open the shader editor in the bottom pane. It comes handily pre-filled with everything you need to get started. We'll be creating a fragment shader, which means that our shader will, in a very simplified explanation, control the final color of the pixel that will be rendered to the screen. In order to get everything working properly, we'll need to texture the model by setting its albedo correctly, and we'll also need to provide a skin color and a hair color for the model to use. The shader will then use those colors along with some mask textures to properly merge everything into the final result. Don't panic, it's easier than it sounds. First thing we'll need to do is define a couple of uniforms. A uniform is basically a function parameter. It provides a way for you to pass data into the shader. We'll need 5 of them in total, 3 of type sampler 2D to represent our textures, and 2 vec4s for the hair and skin colors. If we add the source color hint to the vec4 definitions, Godot will provide us with a color picker to make our lives infinitely easier. Ultimately, we want to set the albedo variable to the final color of our rendered pixel. The first thing we'll do is texture the entire model with the passed-in albedo texture. And we do that by using the texture function. This function takes 2 arguments, the texture to sample from and the coordinates to sample at. Fortunately for us, we don't have to calculate the second value. Godot provides it for us in the predefined UV variable. Okay, so far so good. Now we just have to deal with the skin and the hair. We've got a curveball here in that the skin and hair colors are defined on the albedo, but they're masked so that they don't color the rest of the model. Fortunately for us, Synty provided the mask textures, which is why we passed them in via uniforms. In hindsight, I probably should have looked at the original skin and hair colors on the albedo before I went race swapping everyone, but now we can make them whatever we want, even aliens. So it works out. Anyway, let's sample from the skin and hair mask textures at the UV coordinates. Since the masks are black and white, any pixel not part of the mask will come back as black, which in RGB is all zeros, or white, which is all ones. We can then multiply this value by the actual hair or skin color to get the final color. It'll either be the actual color or black. Next, we have to combine these colors with the existing ones. Fortunately, that's pretty easy. First, we'll do the skin. If the skin color at that pixel is not black, we multiply the skin color with the underlying albedo. We do this because there's a shaded bit of mouth detail in the face that would get lost if we just straight up overwrote the existing color. Next, we do likewise for the hair, except that we don't need to multiply. We can just straight up assign it. Not bad. Make sure to save your shader so you don't lose your work, and let's move on. Now that we have our character fully textured, we can get them moving. Open your browser and head on over to Mixamo.com, and if you haven't already done so, register and log in. Next, find an animation you like. I'm just going to go with a simple walk cycle. Upload the FBX file of your character, and Mixamo will do its patented Mixamo magic to map the animation to its skeleton. Make sure to check the In Place checkbox so the character doesn't wander off, then click Download. Keep the file format as FBX, but change the drop-down that says With Skin to Without Skin. Copy the downloaded file into your Godot projects directory. Godot will import the animation as a blank skeleton and animation player with the animation cycle embedded therein, and we don't want that. So double-click on the file to open the import dialog, and click on the actual animation cycle itself. In the import options dialog on the right, locate the Save to File option and indicate that you want to save the animation as a godot.res file. Now, re-import the file. We're almost done. Open up your character model scene, the one that you inherited from the original FBX file, and add an animation player node if you haven't already. If you goofed and forgot to deselect the animation player from the original file, it's okay. You'll just have to modify the next step a bit. Open the animation editor in the bottom window and click the animation button, then select Manage Animations. If you're working with the original imported player, add a new animation library. If not, you can use the default. In either case, select Add Animation to Library and select the exported res file that Godot created during import. And that's it. Play your walk cycle and strut with pride. If you found this tutorial useful, do that like and subscribe thing, and I'll see you again soon. Bye for now.